Hi, in this video, we're going to talk about the use of a single asterisk in variable number of positional parameters. So I'm going to start with an example of printing a list. Well, we all know how to do that. So if I run this, then the print function takes a single argument, the list, and print it out as a list, right? Now, there is another way to print out all these elements in the list. And you might have seen this syntax before, and that is to precede the list or actually any iterable with a single asterisk. Now, what that asterisk does is that it actually unpacks the iterable into individual or separate arguments. So let me run that. So what it prints out here is each of the elements is an individual argument to the print function. So another way to see this is these two statements, they are exactly the same thing. So what the asterisk does is that it takes the first element, make it into one argument to the print function, takes the second argument from the list, turn it into a second argument, third argument, and so on, until it kind of unpacks every element from the list into individual or separate arguments to the print function. So yeah, again, these two, they are exactly the same thing. So this is in functional method invocation, that if we precede an iterable with asterisk, then it unpacks the individual elements into individual positional arguments. Now that begs the question, then how is print, the function, able to handle a variable number of positional parameters? And that also has to do with the use of a single asterisk. So when we are defining a function or a method, and if we precede a parameter with an asterisk, that makes that particular parameter into what's called a Var-positional parameter. And so what that is, it means it captures a variable number of positional arguments. So I have an example here that I already typed out, that now I'm defining a mySum function here, and it takes an argument, I call it numbers. So I expect a bunch of numbers that I'm going to add up. Now I'm going to precede that with a single asterisk, and then I'm going to, and here inside, I'm going to print the type of these numbers. We'll see what that is, and then we'll go through this, all the numbers, and see what they are. So let's call the function with 3 numbers, okay, and let's run it. So what it turns out to be is that the type of numbers is, it's a tuple, okay? And what's in this tuple, if we print out all the elements in the tuple, then it's these 3 arguments that we call the function with 3, 1, and 8. So if we add another number in there, 9, then this is still these 4 numbers. They still form a tuple that is put into numbers. Okay, so it's the same thing. The type is tuples, and it has 4 elements in the tuple, 3, 1, 8, and 9. This means that if we want to add all of them up, then we can say, the normal way that we'll add up things, and at the end we'll return S. So we can print out what the mySum returns, and that should return us the sum of these 4 numbers, which is 21. And I can even be lazier and say use sum to sum up all the numbers in the tuple. So I can do that. That should give me the same result. There we go. And obviously I can give it any number of numbers here and it'll all work. Things can get more interesting when we mix the var-positional parameters with the normal positional parameters. So for example, I define a full function here. It takes one positional parameter and then a var-positional argument. So let's print out what x is and what arg is when we call full and give it the three numbers. Right, so x is 3 and args captures the rest of the positional arguments. So if I give another, say, two numbers here, then x should still be 3, but the rest of these arguments are again captured by the var-positional parameter. And that's what this slide is trying to explain. Now let's look at a couple more cases of this var-positional parameter. One is the var-positional parameters. It can be empty. So I can call it with just a single parameter or single argument here. And x is 3, right? But there's nothing in args. So args is just an empty tuple. Now, what about if I don't give it any argument at all? Well, in that case, it's not going to be happy because x is a positional argument and it doesn't have a default value. Therefore, it is a required positional argument. So if I don't give it anything at all, it will complain. So things can get even more interesting when we try to pass the variable number of positional parameters to other functions. So let's look at this example here. So it's the same full function that we looked at earlier, but now we also have a bar, that the function that takes one positional argument or parameter y and a variable number of positional parameters. And here we'll print out what y is and what arg is in bar. So let's see what happens. And we call bar from full. Now the parameters or the arguments we pass to it, we take all the positional var-positional parameters that full gets and unpack them so they become individual arguments to bar. So let's see what happens when we call full with 3, 1, and 8. So let's see, 3, 1, and 8 we get, so it comes into full, x gets 3, right? And args in x gets the tuple 1 and 8. Now when we unpack the tuple 1 and 8 as arguments to bar, then 1 becomes y, right? And 8, the rest of the arguments, and that's only 8 here, then that becomes the tuple that is in bar's args. So if we add another 9, let's say here, then the 9 should appear here and here. So let's hope that's the case. And indeed, that is the case. And that's what this slide is trying to explain, that 3 gets assigned to x and 1 and 8 is a tuple that gets assigned to args. And when we unpack 1 and 8, the tuple, when we call bar, then the 1 gets assigned to the parameter y, and 8, the tuple, gets assigned to args. And that's how we get this output. And here is a little exercise for you, that what if when we call bar, we don't unpack it, we don't put an asterisk in front of args? What is going to be the output? So please pause the video, think about it, and after you do think about it, you can try it and see what it is. And here is the output when you run this. It is obviously a little different from what we had before, and please do make sure that you understand why. And here is a slightly more challenging problem for you, that remember this mySum function we wrote earlier, that it can add up all the any number of numbers that are its parameters. And in this function, we use a for loop, so we use iteration to add up all the elements in this tuple. Now, instead of using a for loop, I would like you to try doing exactly the same thing, but with recursion. And to make things simpler, you can assume that there is at least one positional parameter, so there is at least one number that is passed to the MySum function. So go ahead, pause the video and give this a try. Now, if you are stuck, you can unpause the video and I'm going to give you a hint. So, but anyway, give it a try first. All right, so hopefully you have figured it out. If you have not, here is a hint. Well, actually, two hints. So one is, assuming if we don't have to handle variable number of parameters in this function, instead, if this function has one parameter that is a list, then how do we sum up all the numbers in this list with using recursion? Well, this is the way to do it if it's a list. Now, the idea is very similar for a version of this function that takes variable number of parameters. Okay, so that's the first hint. The second hint is we're going to change. We have to change the parameters that MySum takes. So we have to take a parameter, say one of the numbers, so one number x, and then we treat the rest of the numbers as var-positional parameters. So here are two hints, and see if you can see if they help you. All right, so hopefully you figured it out, and here is the answer. So basically, recursion, right? We always need to know what the base case is and the recursive case. So the base case is if there is no other parameter, if there's this number's tuple is empty. So if the length of it is 0, then the sum of that is just x itself, right? There's only one number. Now, the recursive case then is if there are other parameters, there are other numbers in this tuple, then the sum of all of these would be x plus the sum of the rest of the parameters. So I can show that this works. So in this case, we're adding up 3, 1, and 8. That will be 12. I can add another, say, 2 tens into there, so it should give me 32. And if you're still a little fuzzy of how it works, so this will be a step-by-step walkthrough of what happens when we do MySum 3, 1, and 8. So in this case, x would be 3, and the numbers would be the tuple 1 and 8. Now, then the length of this is not 0, so it returns 3 plus MySum. The argument is 1 and 8, right? We unpack the tuple 1 and 8. So MySum 1 and 8, then the x would be 1, and the numbers would be the tuple of 8, just a single number here. So, and again, this tuple, the length is not 0, so it's going to return 1 plus MySum, unpack the tuple, just a number, just one number, so this has just a single number. Now, so when we go into MySum of 8, then x would be 8, and there's no other parameters, so numbers would be an empty tuple, so its length would be 0. So this is the base case here. So in this case, it will return x, which is 8. So 8 is returned here, so 1 plus 8, this becomes 9, and 9 is going to be returned up to this point, so 3 plus 9, and that will be 12, and that will be the answer of MySum 3, 1, and 8. So Python itself makes extensive use of this variable number of positional parameters. So to circle back to what we looked at when we started on this topic, the built-in function print, if you look at the official documentation of the signature or the parameters for print, you can see that its first parameter is a var-positional parameter. So start objects, and that's how you can give any number of arguments to print, and it can handle those correctly.